Okay, Assalamualaikum warahmatullahi wabarakatuh to Prof. Today our group, Mohammad Adib and also me, myself, Nurulasyikin, will present our project which is self-tuning parameter fuzzy PID temperature control in a hydraulic system using STM32F4. This is our term project milestone presentation for code MKEL1123. Next.
So Prof, here is our block diagram. As you can see, what we proposed previously is quite different from this. I mean the concept is the same, but here you can see we implement two of the temperature. One is for reference temperature and one for control temperature. The control temperature is what how the CMC, the SP, and with the hardware abstract set layer works with the PID algorithm library. So it's mean like our PID algorithm library will do the turning system and we control the speed of the fan to cooling the temperature. So it's to cooling our temperature sensor. So it means right now both of our temperature should be simultaneously reading the same value, else it will go through to our PID again and do the tuning again. So it is like a closed loop system. So at the same time, our temperature also will print on the LCD. Both reference temperature and control using PID temperature will print on the LCD using the squared C interface. So for hardware setup, Shiken will explain about this.
Alright, for the hardware setup, so this is our project look like, which the setup is we have a sensor, two sensor LM35, 12 volt DC fan, LED for ADC reference. We have L298N PWN module. We have I2C module, and last one is LCD, which will all these will interface with the STM32F10 board. Next is Adib.
So Prof, here is what we try, what we already implement and we already done. So you can see the video. First, we do the interface, the I2C LCD with the STM32.
Okay, Prof, this is the portion of the I2C LCD. So you can see this is where we implement the I2C and this is the LCD. So the LCD will go to the I2C and connected to our MCU.
So Prof, the second project we do is we implement the ADC for temperature sensor LM35 signal conversion. This is how our signal is coming, is harvest in analog and do the analog to digital conversion at the MCU.
And as you can see, our two LM35 sensor will be connected to our MCU, and here I harvest the when I go to the debug session, which means
So Prof, this is our third progress, and we add the float and unsigned integer 32 value from the temperature sensor to the live watch on the Cube MX IDE video. So by doing this, we can see, we can harvest the data live we can capture the data live on our temperature sensor and print directly to the Cube MX.
so this is where we implement the analog to digital signal conversion. So as you can see, our two LM35 sensor are connected to MCU and propose the analog to digital conversion. And if we go here on the debug, you go to the live version, we can see the live expression of our signal conversion. This is where I harvest the temperature. This is for temperature 1 in float. This is on temperature 2 in float number.
So, Prof, our fourth progress is now we try to print the reference temperature and the control using PID tuning system temperature on the LCD using the I to I squared C interface.
So what I do next is print the to print the temperature value to print the temperature value on the LCD using I to C. So you can see here our live temperature. Sometimes it been like this crazy, but it's work. I mean, yeah, see, it works. But sometimes it's gila a bit. I'm not sure why, but she's okay. Never mind.
So, Prof, this is our fifth progress. What we do here is we integrate the motor driver module L298N into our MCU, the STM32 F4.
So the next part is we control our PWM motor using module L. This one is L298 N. This one is when we send a signal of PWM to our motor, then it will go through this. Then it will active our motor accordingly to the PWM.
So, Prof, this is our sixth progress. What we do here is we try to control our we try to control our module using PWM.
But now, this is how we control our PWM. But now this motor need to supply the 12 volt. But now I don't have, because I'm in office, so I don't have the 12 volt, so that's why it's not working. But when I try to directly put the signal PWM to the LED, then it will the light LED brighter will depend on our PWM. So that's all. Thank you, Prof.
So, Prof, this is how we plan to do next. Now, what we do is like open loop, meaning like current system is like we initialize everything and we configure everything. So, and we hard coded everything. What we try to do next is we try to do the closed loop system. This is how the PID need to work. So, but currently still in start, but we are working on it. Then that is the remaining part we do for this project.
So, Prof, this all our milestone for this project.
Thank you, Prof.
Thank you, Prof.